Hello everybody, in this video we're going to talk about isotopic abundance, and we first have to know the basics before getting into the idea of isotopic abundance. So let's start from this drawing right here. We know that an atom contains of three types of particles: electrons, neutrons, and protons. The atomic mass and the atomic number is basically the number of electrons or protons in an atom, while the atomic mass is actually the sum of number of protons and neutrons in an atom of this element. So this gives you an example of what I'm trying to say here. So let's see, we have two types of atoms here. First is atom Y1 and the second is atom Y2, and we see that they both have the same number of electrons and the same number of protons, while they differ in the number of neutrons. So atom Y1 and atom Y2 have the same number of atomic number. They have the same atomic number, while they don't have the same atomic mass due to the different number of neutrons in their nuclei. So here we have two neutrons. We here have one neutron, and this will change its atomic mass. Well, both of those atoms can be for the same element. Can be for the same element, which is which is the element Y. So this what makes an isotope. So isotope is basically each of two or more forms of the same element that contains equal number of protons but different number of neutrons in their nuclei, and hence a different relative atomic mass. But that does not change its chemical properties, since chemical properties actually have to do with the atomic number and not the atomic mass. Well, let's see what the word abundance means. The word abundance means how much of an element isotope is naturally found in our planet. So the element Y can be found in both forms of atom Y1 or atom Y2, and how much is it we found atom Y1 in our nature, and how much is it to find Y2 in our nature, is what make us set the atomic mass or the average atomic mass in our periodic table right here. Let's see, for example, let's take a silicon. We can see that silicon has an atomic number of 14 up there and an atomic mass of 28.09. So how did they calculate this number to be silicon's atomic mass? Well, silicon actually has isotopes, which have the same number of protons but different number of neutrons, which will result in a different atomic masses. But which one will be chosen to set it here for silicon atomic mass? Should we choose the atomic mass of the isotope with the higher abundance to represent silicon atomic mass? Well, no, it's not. We can calculate the atomic mass as an average of atomic masses of all those forms of isotopes that are found in nature. Let's continue on the example we have about element Y. So if element Y has two isotopes, Y1 and Y2, then the average atomic mass of element Y would basically be atomic mass of Y1. Okay, I keep saying that this Y1, but this is Y2. So atomic mass of Y1 multiplied by the abundance abundance, of y1 in the nature plus atomic mass, okay, of y2 multiplied by the abundance of y2 in the nature. And this rule is basically, you're just gonna basically add the number of, and get the sum of number of protons and neutrons in this atom, and the number of protons and electrons, and protons and neutrons in this atom. So we can have the atomic mass of y1, atomic mass of y2, and then in the given question will be given the abundance of both, which scientists have already calculated for you. So in the next video we will be actually solving practice problems about this topic. Stay tuned.